Hello everyone, welcome to Toppscholars, the smart learning app. Today in this lecture, we are going to discuss something really important. As you can see, we are going to talk about the previously asked questions from the chapter Human Eye and Colourful World from the class 10th Science CBSE, isn't it? So, in this lecture, we are going to talk about the previously asked questions from the last 5 years. That means from the year 2019 till last year, that is 2023. So, this lecture is going to be very important if you are preparing for the board exams of class 10th CBSE, isn't it? So, let's get into this lecture and let's see what are those questions that have been asked in the last 5 years. Okay, moving on. Before exactly we get into these questions, let's first analyze this chart properly. This chart actually talks about how many questions were asked for 1 mark, 2 mark, 3 mark, 4 mark and 5 mark year wise. As you can see, 1 mark question, you can see here total 4 questions have been asked in the last 5 years. In the subsequent years, let's say here in 2021 there was 1 question, 2022 we had 3 questions for 1 mark, total 4 questions, and definitely this is for total 4 marks. Then if you talk about 2 mark questions, then in the year 2019 we have 1 question, then again here 2023 there is 1 more question, so total we have got 2 questions and for 4 marks. Next, if you look at the 3 mark questions, then here you can see in the year 2019 we have got 1 question, 2020 we have got 1 more question, then total question we have got 2 and here the total marks are 6. Then 4 mark question, if you look here we have got only 1 question from the year 2021 and in this way we have got total 4 marks. And the last we have got the 5 mark question, and there was 1 5 mark question from this chapter in the year 2020, isn't it? And definitely it was for 5 marks, isn't it? So this is how it has been so far for the last 5 years. Okay, so we can see here in total we have got 4 plus 2 6, then 8 9 and 10. In the last 5 years there have been 10 questions asked from this same chapter. Now what we are going to do is we are going to discuss each one of these questions. Some of the questions will be discussed in short, but some of the questions will be discussed in details. Okay, so let's move on. Let's dive into all these questions and let's see what exactly were those questions. Before that, let's just have a look at this graph. This is the same data which has been shown graphically. This is the same thing that we have seen in the table previously. Okay, this graph shows nothing but the number of questions that were asked year wise for different marks. Okay, so this is again the same thing. So we are not going to go into details of this graph. Now moving on. So these are the questions. Now we are starting with the questions. So first of all, starting with the year 2019. So the first question in the year 2019 is define the term power of accommodation. Write the modification in the curvature of the eye lens which enables us to see the nearby objects clearly. Okay, so this is a short question and it was asked for 2 marks, and this is a very easy question. As you can see, it is related to eye lens, isn't it? It is related to the topic eyes, human eyes, isn't it? So here we have to write the modification in the curvature of the eye lens which enables us to see the nearby objects clearly. That means how the eye lens changes its shape, how it changes its thickness, okay, and how it accommodates, isn't it? How it accommodates to see the world around itself, see the objects nearby. Okay, so this is what we have to discuss over here. Then the next question over here is, what is rainbow? Draw a labeled diagram to show the formation of a rainbow. So how exactly rainbow is formed, that is what we have to show here. This is again a short question asked for 3 marks. So this is a quite important question because you can see it's asked for 3 marks, right? So here we have to draw that diagram of the water droplets, isn't it? And through which we have to show the rays of light which are passing and how exactly they disperse into 7 colors. So that is what we have to show here. We have to define what exactly is a rainbow. Okay. So this is the short question from the year 2019. Moving on to the next, that is 2020. So in the year 2020, this is one of the short question asked for 3 marks. Okay. And this question is, draw a labeled diagram to show reddish appearance of the sun at the sunrise or sunset. And next, the white appearance of the sun at noon when it is overhead. So over here in this question, we have to draw the neat labeled diagram. So over here we have to show the earth, then its atmosphere, then we have to show the sun at the horizons in the both of the directions. That means during the sunrise it should be in the east, then during the sunset it should be at the west. Okay. Then for this one we have to show the sun overhead, isn't it? And we have to show exactly how the rays of light are traveling. Over here what happens, how the rays are traveling larger distance through the atmosphere. That is what we have to show over here, isn't it? So this is what we have to indicate over here. Okay. So this is a quite simple question. Over here we have to just draw some diagrams and it is all there in our books also, isn't it? Moving on to the next, year 2021. So here is one MCQ question for 1 mark. Which one of the following is the correct reason for twinkling of stars? Okay, twinkling of stars. So why do stars twinkle? We know the reason, isn't it? So here the options given are, first one, atmospheric reflection of starlight, then atmospheric refraction of starlight, then scattering of starlight, and the last one is dispersion of starlight. So these are the 4 options that are given, out of which, as we know, this phenomenon, that is twinkling of stars, it happens because of atmospheric refraction of starlight. So when the light from the star enters our atmosphere, it refracts, and since the density of the atmosphere at different places at different times keeps on changing because of clouds and everything else, the gases, dust particle, everything else, due to all these things, the stars appear to be twinkling. So this is all happening because of the atmospheric refraction of the light. Okay. So this should be the option of this question. Okay. Moving on to the next question, again from the year 2021. So it's a case based 4 mark question. Okay. So here some case is given, a large paragraph is given, you have to read this paragraph, and from this paragraph, okay, you have to draw some conclusions and then you have to answer the questions that are given below this paragraph. Okay. So first over here, study the following and answer any 4 questions from 1 to 5. So the case is, light seems to travel along straight line paths in a transparent medium, but when light enters obliquely from one transparent medium to another, some changes are observed. This is because different mediums have different optical densities. The extent of the change in the direction of light that takes place when it enters obliquely in a given pair of media is expressed in terms of a constant. Light travels the fastest in vacuum. Light gets refracted through a transparent prism. Several phenomena are observed due to the reflection, refraction dispersion and scattering of light by various mediums. So we have to read this paragraph very carefully, understand it very well, and then draw some conclusions out of it, and then only we have to answer the questions, okay, which are given below this paragraph. So the questions given here are these ones. Okay, what we are going to do is, for now we are not going to solve these questions. Later on, at the end of this lecture, we are going to solve these questions also. Okay, so right now we are just going to look at these questions. The question is, rainbow is a natural spectrum. It is produced because of, these are the 4 options that are given. This is for 1 mark. The next question is, in the given diagram showing refraction of a narrow beam of a monochromatic light through a glass prism, the angles marked 1 and 2 respectively are what? Okay, so this is one more question. Okay, again it is for 1 mark. This is again based on the same case that was given previously. Okay, next we have got these 2 more questions. Blue color of clear sky is due to what? So we have got 4 options. Then the apparent flattering of the sun's disk at sunrise and sunset is due to what? Again we have got 4 options. Okay, again this is for 1 mark. Moving on, we have one more question based on the same case for 1 mark. Consider the following statement. Very fine particles scatter mainly blue light, then advanced sunrise and delayed sunset. Then we have got violet light bends the least while red light bends the most when a beam of white light passes through a glass prism. Okay, so the correct statements is or are what? So we have to find out which of these are the correct options. Okay, now we are moving to the year 2022. So here again, which of the following statements is not true for the scattering of light? Okay, so here is the question. We have got some statements. Color of the scattered light depends on the size of the particles of the atmosphere. Second one, red light is least scattered in the atmosphere. Scattering of light takes place as various colors of white light travel with different speed in air. The fine particles in the atmospheric air scatter the blue light more strongly than red. So the scattered blue light enters our eyes. So here we have to identify which one of these statements is not true. That means false. So let's look at these statements. Each one of these statements represents something, and once you identify, you are going to get 1 mark for this. Okay. So for example, if you look at this, the fine particles in the atmospheric air scatter the blue light more strongly, isn't it, than red. So the scattered blue light enters our eyes, and this is a true statement, isn't it? And that is the reason why the sky appears blue to our eyes. So this is going to be true. Okay. Then if you look at this statement B, red light is least scattered in the atmosphere. And again, this is true because red light generally does not scatter much, and that is why it is used in traffic signals, then danger signals, isn't it? So that people can see that traffic signal or danger signal from a very long distance, because red light can travel very long distances in the atmosphere because it is not scattered as much as blue light. Okay, so this is again a true statement. Okay, then here it is. We have got next one. Color of the scattered light depends on the size of the particles of the atmosphere. And we have got one more. Scattering of light takes place as various colors of white light travel with different speed in air. So definitely, if you look at this statement, over here it is written scattering of light takes place as various colors of white light travels with different speed in air. So definitely this statement does not look true. But if you look at this one, color of the scattered light depends on the size of the particles of the atmosphere, which is true. Basically, scattering depends on the size of the particles itself, isn't it? Okay, so that means this option C is the correct option, or we can say it's a not true statement. That means it's a false statement. Okay, moving on to the next question from the same year 2022. In the diagram given below, X and Y are the end colors of the spectrum of the white light. The color of the Y represent the, so we have got four options over here. So here is a prism, okay, and here is the white light which is entering, and you can see it is entering, and after entering it is dispersed into its component colors. So over here X and Y are representing the end colors, okay, you can say extreme colors, okay. Now here are the four options that are given. Color of the sky as seen from the earth during the day, okay. Color of the sky as seen from the moon. Color used to paint the danger signals. Color of the sun at the time of the noon. So here we have to identify what is Y. So Y is over here. So as you can see, white light is entering into the prism and it gets split into two colors. One is Y and one is X. Okay. So we can see here Y is least deviated, whereas X is most deviated. So as we know, the color that is least deviated is the color with longer wavelength, and the color which is most deviated is the color with shorter wavelength. Okay, and the color which is definitely deviated with small angles is nothing but the red, isn't it? And the color which is deviated with large angle are towards the violet end, or maybe little bit close to blue. Okay, so definitely Y should be a red color and violet should be the, X should be the violet color or blue color. Okay, so Y over here represents the red color. That means the color used to paint the danger signals, because we know in danger signals we use red colors. Okay, moving on to the next question, again from the year 2022. So here we have got assertion and reason. So sun appears reddish at the time of sunrise and sunset. So this is the assertion that is given. Sun appears reddish at the time of sunrise and sunset. Then reason is distance traveled by the sunlight in the atmosphere is lesser during the sunrise and sunset as compared to the noon. So definitely here are some options that are given, but if you look at these two statements, definitely the reason that is given is not correct, isn't it? Basically, the distance traveled by the sunlight in the atmosphere is actually larger during the sunrise and sunset, and here it is written lesser, so this is wrong, isn't it? So let's now look at the options. Both A and R, that is assertion and reason, are true. Okay, so definitely the reason is not true. That's why this should not be the option. We should not bother reading ahead. Okay, then second one, both A and R are true. Again, here it is written true. So again, since reason is not true, this is also not the option. Then C, A is true, which is actually true, right? Sun appears reddish at the time of sunrise and sunset. So this is right, and R is false. Again, this is also right. That means this should be our option, and last option is A is false. Again, this is wrong. R is true. Again, this is wrong. So the correct option should be C. Okay. So this should be your answer for this simple question. Okay. This is for 1 mark. Okay. So here in such a questions, we have to also explain what is right and what is wrong. If such a statement is given, then why this reason is not right, okay, and whether this reason is correct reason for this assertion or not. That is what we have to justify over here. But since this reason is not right, then we have to actually explain why this reason is false and why it is not the actual reason for this assertion. Okay, so this is what is expected in such a question. Okay, assertion and reason questions actually want that kind of an answer. Why assertion is right? Okay, if it is wrong, why it is wrong, and why reason is right. If it is wrong, then why it is wrong, and if it is the reason for assertion, then why it is reason. Okay, if it is not really the reason for this assertion, then why it is not the reason. Sometimes it may happen that the reason is true, but it is not the correct reason for this assertion that is given. Okay, so in that case also we have to explain why it is not the reason for this assertion. Okay, so this is for 3 marks. Okay, moving on to the next question. Now we are moving to the year 2023. So this is a 2-mark question. Okay, so here is a question. A narrow beam XY of white light is passing through glass prism ABC as shown in the diagram. Okay, trace it on your sheet and show the path of the emergent beam as observed on the screen PQ. Name the phenomenon observed and state its cause. Okay, so over here we have to complete this diagram. What exactly will happen over here in this case? Okay, and we have to name the phenomenon observed and state its cause. One more option for this question is given, and that option is this one. That means if you want to solve that, you can solve that, or else you have another option. It is observed that the power of an eye to see nearby objects as well as far objects diminished with age. Okay, give reason for the above statements. Okay, then name the defect that is likely to arise in eyes in such a condition. Okay, draw a labeled ray diagram to show the type of corrective lens used for restoring the vision of such an eye. Okay, so here we have to explain everything about the defects in eyes, right? This question actually wants that kind of an answer, right? Why does the vision diminishes as the age progresses? That is what we have to answer over here. What are those actual defects? Okay, whether it is myopia or hypermetropia, that is what we have to explain over here. Okay, it may be cataract also, so we have to explain that also over here. Okay, then we have to draw the ray diagram also, and what are the corrective measures, that is what we have to show over here. Okay, so this is for 2 marks. Moving on to the next. Now what we are going to do is we are going to solve some of the questions. Okay, actually, okay, we are going to show some solutions for the questions that were asked. This is from the year 2023 for 4 marks. Okay, so here as we can see, a paragraph is given. That means some statements, some content is given, and we have to read it very carefully and understand very carefully. Light seems to travel along straight line paths in a transparent medium, but when light enters obliquely from one transparent medium to another, some changes are observed. This is because different mediums have different optical densities. The extent of the change in the direction of the light that takes place when it enters obliquely in a given pair of media is expressed in terms of a constant. Light travels the fastest in vacuum. Light gets refracted through a transparent prism. Several phenomena are observed due to the reflection, refraction, dispersion and scattering of light by various mediums. So this is everything that is given, and as we can see here, it is related to different phenomenons associated with light, maybe refraction, maybe dispersion, maybe scattering, etc. Okay, so now On the basis of this case that is given here, we have 5 questions that are given over here and we have to answer any 4 of these questions. Okay, so let's have a look at all these questions. Okay, so the first question over here is, rainbow is a natural spectrum. It is produced because of what? So first option is dispersion of sunlight by tiny water droplets, refraction of sunlight by dust particles, reflection of sunlight by plain shining surface, and last one is scattering of sunlight by tiny water droplets. Okay, so let's have a look at the solution. As we all know, rainbow is natural spectrum. It is produced because of dispersion of sunlight by tiny water droplets, typically after a rain shower. These droplets act like prisms, separating the sunlight into its various colors and creating the colorful arc we see in the sky. Okay, so over here the correct answer is dispersion. Whenever the ray of light coming from sun enters the very small water droplets, okay, over there inside that water droplet it gets dispersed. Okay, that means it gets separated into 7 colors, spread into 7 colors. This is because all these 7 colors would have different refractive indices with respect to the water, and therefore it travels in different directions, and that's why we see 7 colors of the rainbow. Okay, so this is a very easy question. Moving on to the next one. Again, this is the case that is given. Okay, and on the basis of the case we have this question. In the given diagram showing refraction of narrow beam of a monochromatic light through a glass prism, the angles marked 1 and 2 respectively are what? Okay, so here you can see this is a prism, this is the incident ray, this is the refracted ray, and this is the emergent ray. Okay, here is the normal, again here is the normal, the dotted line is the normal drawn to both of the surfaces. Okay, so we have to identify what is this 1 and 2 angle. So the answer is pretty simple, isn't it? In the given diagram showing refraction of narrow beam of a monochromatic light through a glass prism, the angle marked 1 and 2 are incident angle and emergence angle respectively. That means this one is angle of incidence, isn't it? And this one is angle of emergence. Okay, so these are the 2 angles that are shown over here. Okay, so this is again a pretty easy question. Moving on, again this is the same case that is given. On the basis of this case we have this question. Blue color of clear sky is due to what? Okay, refraction of light, reflection of light, absorption of light, or scattering of light. Okay, so the correct option over here is, as we all know, this happens because of scattering. The blue color of the sky happens because of scattering of light. When sunlight enters the atmosphere, blue light with shorter waves is scattered in all directions by gases and particles, making the sky look blue. During the sunrise and sunset, the sun's light has to pass through more atmosphere, scattering shorter wavelengths and allowing longer wavelengths like red and orange to dominate, creating warm colors. Okay, so basically blue color of the sky during the daytime happens because of scattering of light. The same thing we observe in the evening, right? In the evening time and in the morning time, we observe that the skies appear reddish or little bit orange, and that happens because at those times the sunlight has to travel very large distance, okay, through the atmosphere as compared to the noon time. Okay, so because of that longer distances, blue light gets scattered in the different directions, but red light, which has a longer wavelength, does not scatter much. So it just travels through, and that's why we get to see red color or orange color during the sunset and sunrise. Okay, so this is a simple answer or simple explanation for this question. Moving on to the next, again this is the case. So let's move on to the next question. The next question is, the apparent flattening of the sun's disk at sunrise and sunset is due to what? So we have got four options: dispersion, scattering, atmospheric refraction of light, and the last one is Tyndall effect. So as we know, the answer is very simple. The apparent flattening of the sun's disk at sunrise and sunset is due to the atmospheric refraction. If the sun is low above the horizon, the optical path of the light through the atmosphere is very long, and the atmosphere usually has a layered structure, right? Refraction of the light by these layers can cause the sun's disk to be deformed, flattened or distorted. That means it is very simple. If you look at the sun while sun is setting or sun is rising, then in that direction of the horizon over there, the light travels a longer distance. And the thing over here is, the atmosphere has different layers. The atmosphere has different layers. That means every layer has got different optical density. That means the ray that is coming from the top of the sun and the ray that is coming from the bottom of the sun, it refracts or it bends little bit differently. Okay, the angles of deviations are different for both of these rays, and that is the reason why the sun appears to be flattened, okay, during the sunrise and sunset. So this is the correct answer, option number C. Moving on to the next question, and this is the same case that we have discussed many times, okay, and the question is, consider the following statement: very fine particles scatter mainly blue light. Second statement is, advanced sunrise and delayed sunset are due to atmospheric refraction. Next is, violet light bends the least while red light bends the most when a beam of white light passes through a glass prism. The correct statements is or are 1 only, 3 only, 1 and 2, 2 and 3. So out of these 3 statements that are given, we have to identify which of these are correct. Okay, so the correct answer for this is second only. That means this one, advanced sunrise and delayed sunset, they happen because of atmospheric refraction. So we know what is advanced sunrise. We get to see sun 2 minutes earlier than its actual rise time. Okay, and same thing happens during the sunset. We get to see the sun for 2 minutes more. Okay, that means the sunset happens little bit delayed. Okay, and that is because of the atmospheric refractions. Okay, over there the rays bend in such a way that we get to see the sun for quite a long time. That means extra 2 minutes. Same here during the sunrise. Okay, so that means this is the correct statement. Okay, so the correct answer is B. Moving on to the next one. In the diagram given below, X and Y are the end colors of the spectrum of the white light. The color of Y represent the what? So options are color of the sky as seen from Earth during the day, then color of the sky as seen from the moon, color used to paint the danger signals, then color of sun at the time of noon. So we have already discussed this question, but still let's discuss it again. So we have a white light, then after refraction through the prism it has dispersed, and you can see we have one ray and another ray, Y and X. Y has bent less and X has bent more. So as we know, the color that bends less is generally red in case of a white light, and the color that bends more is nothing but violet or bluish color, right? So that means here we have been asked to find out y, right? So over here definitely y is the red color. That means the color used to pen the danger signals, isn't it? So over here in this case it should be the red color. Okay, so this is our solution. Okay, C is the correct answer. Moving on to the next question. Okay, which of the following statements is not true? That means it is false. Okay, again we have discussed this question previously also, but let's discuss again. Color of the scattered light depends on the size of the particles of the atmosphere. Second statement is red color is least scattered in the atmosphere. Then scattering of the light takes place as various colors of the white light travel with different speed in air. Then the last statement is the fine particles in the atmospheric air scatter the blue light more strongly than the red. So the scattered blue light enters our eyes. So these are the four statements given and we have to find out which one is false. So out of these, definitely the false statement is C, this one. Scattering of light takes place as various colors of white light travel with different speed in air. So this is basically not the correct answer because scattering of light generally does not take place because of this reason that is given over here. Okay, so that's why this is wrong answer. Okay, that means this is the false statement. And if you look at these other statements we have discussed previously also, this is correct. Okay, so this is going to be the correct answer for this particular question. And so we have now come to an end of this lecture. Okay, now in this lecture we have discussed previously asked questions from the chapter Human Eye and the Colorful World, isn't it? And we have discussed all the questions since the last 5 years, and so that's why this is a very important lecture for all of you, isn't it? And I hope everything that we have discussed in this lecture is very much clear and well understood to all of you. So thank you so much for watching this video. Thank you.